In this video, I'm going to show you a few examples of subtracting rational expressions. Now, it will be really helpful for you if you've already watched my video about adding rational expressions, because we're going to follow the same steps that we followed in that video, except there's a subtraction sign in between the two fractions instead of addition. So to make these denominators match, we are going to multiply an x to the numerator and denominator of the second fraction. I'm going to write that x in red. Now, the 3 doesn't have an x, but that's okay, because this denominator, we didn't change this fraction at all. We just made a slight adjustment to the first fraction, and now we're ready to subtract. The common denominator here is 8x. And so we're going to take a look at the numerator and collect like terms. Well, our numerator is 5x minus 3. Those are not common terms, and so you are really just going to write 5x minus 3 across the numerator. This is your answer. There is nothing more we can simplify here. Even though both of them contain an x, we can't simplify just that part of the problem out, because this x is being multiplied times 5 and then subtracted by 3. And so it's a big mess. We can't go there. So since we're not totally sure what the x is, there's your final answer. Okay, take a look at the second example. Automatically, you may notice that the denominators are a little more complicated than this previous problem. When you have bigger denominators, I want you to first see if you can factor either of the denominators. This first one you can, and I'm just going to write the factored version just right below here. You can take a 5 out, so I can rewrite this as 5 times x minus 6. Now, the reason I want you to factor when you can is because it's easier to see if there's any part of the denominators that already match. Because right now, if you just left it as the 5x minus 30, first glance, it looks like it doesn't match with the x minus 6 at all. But it actually does, because inside here was an x minus 6. The only part of the denominator that's missing is the 5. And so this problem is really easy to find the missing part. We just have to multiply over here by 5. I'm going to put parentheses around both of them. In red, I'm going to write just a times 5. Okay. So the common denominator, and you can leave it, we'll just leave it like this, the 5 times x minus 6. Okay. Now I want you just to focus on the numerator. We're going to collect like terms. Before you do, we need to go ahead and multiply the 5 through on that second denominator. So, and you know what, let's go ahead and drag this subtraction sign with us, because it will make it easier when we do collect like terms. So this is going to be minus 15x, and then if we do the negative 5 times the 4 is minus 20. Okay, so since we pulled that negative through with us, we could really just put a plus sign there. Okay, so take a look. Let's do this in descending order. So 2x, when you combine that with a negative 15x, you have negative 13x. And then 3 plus the negative 20 is negative 17. And that's it, guys. That's your final answer to the second example. Okay, let's take a look at this last example together. Remember, the key when we are adding and subtracting rational expressions is to make those denominators match. The only way we can change or alter the denominator is through multiplication. So even though both of these already have an x, it's not like we can, subtract some from the 7 to make it a negative 3 as well, because you can't subtract in the denominator. You can only multiply to make that change. So right now, these two denominators have nothing in common. And so when you're in this situation, we are going to take the denominator of the first expression and multiply it to the second fraction. And then we're going to do vice versa, the second denominator multiplied by the first. So I want you to rewrite this problem, and I want you to go ahead and make that fraction bar a little longer than this original one. Okay. I'm going to write the original fraction in black marker. And go ahead and put parentheses around these original denominators just to kind of keep them together. In this red marker, I'm now going to multiply this first fraction times the second denominator. It does have to be multiplied by the numerator and denominator. Got to keep it fair. Okay. Then we're going to do the same thing with the second one. We're going to do x minus 3 and then x minus 3. All right, so we already have common denominators. It's x minus 3 and x plus 7. So you can actually go ahead and start creating our answer, x minus 3. And it doesn't matter in which order you have these factors in the denominator. Okay, i's in the numerator. We need to collect like terms across this numerator, but before we do, we need to do a little bit of algebra first. Distributive property, I'm going to just write it to save space directly above here. This will be 2x plus 14. And anytime we're doing a subtraction problem, I want you to drag this subtraction problem with this coefficient. So this will be negative 1 times x, which we can just put the negative x, and then negative 1 times negative 3 is positive 3. Okay, so by dragging that over, we could technically change that to a plus sign if you want. Okay, now collect like terms, and I want you to keep it in descending order. So 2x minus x is x, and then 14 plus 3 is 17. All right, it's your turn. Pause this video and you're going to see some questions. I really do want you to work through them for some extra practice.